Hey, welcome back. This morning talks were to listen to. We're going to start moving on. It's incumbent upon us to start using our data and looking at it in a way that it's going to benefit all of our communities out there. And we're moving into some talks that will look at the data that we're collecting and how we can start visualizing it. We're collecting vast amounts of data every day to try to make sense of and make decisions about our world. And the quality and usefulness of some of the data can vary between agencies and programs, and formats are often specific to the data collector, and it makes it difficult to understand and integrate some of these sets of data. In this session going forward, from data to insight, we'll be introduced to some portals and visualization tools that can help with some of these issues, making those data more accessible to scientists and decision makers so that we can protect some of these communities that are marginalized, so that we can move on and use the data in much more usable ways. So starting us off for this session is Emily Richardson with the U.S. Geological Survey. She's going to be introducing the Bay Delta Data Sandbox, a web-based analytics and visualization environment for accessing and experimenting with integrated Bay Delta data. So as soon as you're ready, Emily, you're on.
Okay. Requesting control. Okay. Well, good morning, everyone. I'm so honored to kick off the data talks today. Thanks for joining. I'll be diving into my group's initiative to create a Bay Delta data sandbox. First things first, I'm Emily Richardson. My pronouns are she, hers, and I'm a USGS water researcher in the California Water Science Center's Biogeochemistry group. I actually moved to Sacramento from East Tennessee early on in the pandemic, which was difficult on many levels, including starting a data-driven job in the Bay Delta, which, as y'all know, is an area where so many different groups are collecting so many different types of robust data. And don't get me wrong, that's fantastic, especially in such a unique system, but it can also be very overwhelming for a newcomer, as I learned firsthand, especially when I don't even have those hallway chat connections. There are so many acronyms to learn, so many different research focuses within each working group. There are federal researchers, state universities, nonprofits, etc. It's a lot to navigate through. And that's why we want to bring together important data from across entities who collect them and make them easily obtainable for many different types of data users in one central location. For example, in addition to getting to play with data, I get to collect it. Last year, I took part in many huge Delta-wide surveys. There I am on one of our boats, and my colleagues and I noticed a ton of algal blooms throughout the Delta. You'll notice that we are not photographers, so this is the best image we could get of it. But each time we were out there, we saw these blooms to varying degrees. And even this year, we have noticed some flakes in the water, but less drastic than blooms like this, thankfully. We believe this species to be microcystis, which is a type of cyanobacteria. And of course, we won't be 100% sure until the data gets back. But this really piqued my interest. I'm told it's not usually like this, but yet every time I've been out in the Delta, I can visibly see scattered colonies in almost every reach I've been to. So now I'm curious, and I want to look at cyanobacteria's presence in the Delta over time. And I know that data has to exist here, and I want to get my hands on it. But how do I know who collects it? How do I know where to look or who to ask as a newcomer, or even as a seasoned professional? Y'all know how many groups there are in the Bay Delta. It's a lot to remember. How do I know what format the data will be in? When was it collected? How was it collected? Where are the methods? Say I'm lucky enough to type in the perfect Google search to find it all, or I happen to know somebody who holds all the answers and can point me in the right direction. So say I do get my hands on these data sources. Now I have access to rich data, but they're locked up in the beautiful webs of an Access database that I need to untangle. Or I might need a certain software to grab it, or learn a new coding language. Maybe I'm lucky enough to find 5 different CSVs. Now I can just append them together, right? No, the formats don't match. So now I need to convert coordinates, date time formats. Maybe one group reports cyanobacteria in cells per liter, one in cubic micrometers per centimeter. How do I manage that? How do I know if data collected from site Z7S from a state agency is comparable to site LPS from a federal agency? Now, after I've sliced, diced, transformed, and asked a million people a million questions, how much time have I lost? Probably a lot. Enter the data sandbox, where our group of water-focused data folks have done all of this slicing, dicing, wrangling, and harmonizing for you. Now I can say, hey, there's a phytoplankton dashboard. That's where I can get harmonized cyanobacteria data. I can enter the phytoplankton dashboard, access data from across agencies that have been harmonized to the same units and spatially and temporally aligned. Here we have awesome long-term data from DWR's environmental monitoring program, blended with USGS phytoplankton data. I can filter down to my desired time frame using the date time slider up here. And I can also reference this map to see where my sample locations are. I can reference this legend over here. We have designated areas using a tool we've created. We are working on making more granular and more broad grouping, so that's pretty excited. I'm also particularly excited about this N number value here. You can watch it change as I apply filters. That's something I particularly enjoy. So I can reference this legend here, uncheck all of my regions that I am not interested in. Say that I notice there is still a stray point that is outside of my target location. I can click on that point, get a little more info about that site in particular, and I can exclude it from here. Or maybe I'm colorblind, and that legend was never helpful for me at all. I can use this lasso select tool, simply circle my area of interest, and exclude all points outside of it. I can even begin to make insight from within this sandbox. So these figures here were created after consulting subject matter experts as meaningful ways to display these data. For instance here, given all of my filter parameters, I can hover over each grouping, get more information on them. I can reference the stacked area chart in the lower left corner that references phytoplankton in density in organisms per milliliter over time. And I can filter down to maybe just the broader groupings, the more dominant algal types that I want. Or maybe I'm only curious about microcystis. I can even filter down all of these visualizations to just one genus. And I can see some big differences. Let me toggle back and forth between the last view and this one to point out some preliminary insights. Check out this map. When I remove the microcystis filter, more sites pop up. So I can tell that microcystis hasn't always been collected at each site. When excuse me, it looks like microcystis grows best in summer and fall, whereas other cyanobacterial species seem to do best in winter and spring. I can also see this axis here changing on the bottom. So since my filter parameters included 2008 to 2019, and this legend or this axis here only has data starting at 2012, I can tell that microcystis wasn't collected at these locations from 2008 to 2011. And that just so happens to be the time frame where this big shift happens. So now I'm thinking there could be another layer to my initial research question. And I want to check out food web dynamics because I'm pretty sure diatoms are an important food resource and their numbers are seemingly dwindling. So I'm going to click my home button and go back to the portal. I can navigate to another dashboard I want. Is this window popping up for everybody? It's okay, I'll continue. Okay, so if I don't know exactly what I'm looking for, I can use this handy dandy data source structure, which as I've noted here is a work in progress and it's not live yet, so bear with me. But I can enter this dashboard and I can see what data is available. I can see which agencies collect them, and I can also see which visualizations they are included in. And I can also filter down by agency, by parameter, and by visualization. And if I don't see the data I want, or if I have an idea for another way to visualize them, I can fill out a request form. We're working with SFEI to get a search engine going as well, so that'll be very useful. And here, just by glancing, I can see that this bio dashboard should contain the data I want, since it has phytoplankton data as well as zooplankton data. So I'm going to go back to my portal and enter the bio dashboard. So this dashboard contains a ton of long-term zooplankton data shown here, as well as long-term clam data shown here, as well as the phytoplankton data that you just witnessed. The Interagency Ecological Program is great at sharing open source and harmonized data. The zooplankton data I grabbed from the Zooper Our Shiny app, which I believe is spearheaded by Sam Bishevkin and Rosie Hartman et al. The clam data I tried to grab in the middle of an EMP website upgrade, and Betsy Wells at DWR, very gracious, sent me all the data I could ask for and more. Also, Tiffany Brown, DWR, very grateful, with helping me grabbing all the phytoplankton data. I will get off my fan club soapbox. There's just a lot of great research and dissemination projects out there, and we'd love to be a part of it. So back to my dashboard, I can enter my filter parameters here that I want, that I had in my last visualization. So I changed my date time range here, and I clicked all the subregions that I wanted. I also excluded that stray point. I can highlight a figure that contains all of the data that I want. There we go. I can click this View Data button. And from here, I am able to export as a CSV. We are also in the process of getting a data download button up and working, so stay tuned for that. That would mean no highlighting the data. You just simply enter in your parameters, click a button, export everything as an Excel file. So stay tuned for that. And if you aren't interested in phytoplankton, which I think everybody should be, but if you aren't, we still have useful data for you in the sandbox, like long-term continuous monitoring of many types of water quality parameters. We have weather data, we have statewide California data, not just Bay Delta. You better believe we're getting Ferry and brine shrimp into this visualization. We are actually actively working on that. And this is just the tip of the iceberg. We'd like to get much more in there, and we think it'll be a really useful tool and a great way to unify and promote exploration of our collective Bay Delta data, which will benefit everyone. We have more plans in the works, like easy metadata downloads, links to original data sources, those are more components of our SFEI partnership. And also finding better ways to credit the data sources within these visualizations. So I should have time for some questions, but if I can't get to yours, or if you think of one later, or if you want to learn more about this, be sure to check out the workshop tomorrow that our group's putting on. Here's a link to register up here. We'll go over the ins and outs of the data sandbox in greater detail, and we'll have some fun demos too. And thanks for listening.
Hey, thank you for a great presentation, Emily, and for helping summarize some of the issues we all face with using data from different sources. Let me check and see if we have any questions for you. I think, Peter, do we have any questions?
Yes, we do. Diala Jawari is wondering if we could get a copy of the presentation. She was unable to see it on the screen. It was too small.
These are being recorded, right? Are they going to be posted anywhere?
So everything's going to be recorded. Sharing presentations is up to the presenter.
Okay, yeah, you can maybe email me. I can send you a copy.
Okay, thank you.
Okay, thank you. And Peter, are there...
One more question. I may have missed this. This is from Melissa Foley. I may have missed this, but does the sandbox automatically aggregate data from sites like CEDN and CD3?
So it depends on how we create the visualizations, but what we had showing there, we didn't aggregate across different sites. So all the aggregations that happened were with the filter parameters. So no, the visualization you saw, each site was showing individual data.
Thank you.
And whenever you download the data, it's not aggregated.
Okay, thank you again. It looks like there's a couple more questions came in, Peter.
Oh, sure enough. Is the Bay Delta sandbox currently and freely available? What is the URL?
Great question. Realized this morning I didn't send a link. So yes, it is free to use. I have a link I will be posting. Not sure how to post it. Oh, I can answer here. Let's see. Type answer. Here we go. I'm wondering if I sent it.
It's gone. I think so. And
Okay.
I'll try to make it more available to.
Okay, and if you come to this workshop, we will share that there as well.
Thank you. Is the effort connected with dataca.gov efforts for more accessible and transparent data?
Not officially, no. But if that's an offer, we'd like to talk about it.
Thank you. That's it.
Okay, so if that's the end of the questions, again, I'd like to thank you for that wonderful presentation, Emily. And for anyone who does want to learn more about the Bay Delta Sandbox, there's the information about the workshop there on the screen. That's going to be tomorrow afternoon from 1:30 to 4. So if you are interested and want to learn the answers to some of these questions, oh, and it looks like Anna has just put up a link to the sandbox in the chat. So if you are interested and wanted that link, it is available there. So thank you again, Emily. And we will start moving on. Our next presentation is about Delve, a cloud-based data management and visualization system for standardization, exploration, and collaboration. And we've got two presenters, Mike from Environmental Science Associate and Laura Nickelhoff from Sitka Technology Group. So if you're ready, the platform is yours, Mike.
Thank you. And I think we're just going to take a second here for Laura to take controls. Laura, can you just let me know when you're ready?
I think we're ready. It's a little delayed. There we go. Good to go.
Okay. Great, thanks. So hi, my name is Mike Leech, Geospatial and Technology Services Lead at ESA. I'm a member of the consultant team supporting DWR O&M with implementing the system called Delve. Joining me is Laura Nickelhoff from Sitka Technology Group and product owner for this effort. Next slide. So the impetus or driver for this work is the Open and Transparent Water Data Act, or AB 1755, which I'm sure many of you are familiar with. Additionally, DWR O&M needed to build a more permanent data management system for existing and future data sets for DWR Delta projects for compliance and special studies between Delta Conveyance and the South Delta. More specifically, the overarching goals of this system include implementing a set of data standards and protocols that will aid in transforming data into machine readable and usable formats and help improve collaboration with front-end search, query, analysis, and visualization and export functionality. And doing this all with a modern technology stack and system architecture that leverages cloud-based services and tools. Next slide. So the initial step of this project was to perform an assessment of the Bay Delta Office repository in terms of the scope, scale, quality, condition of the existing data sets in the repository. The review led to the organization of data sets into a set of data categories that could be structured with a set of data standards that existing and new data by category could be validated against, such as the ADCP, acoustic telemetry, organism sampling, experimental observations, etc., along with non-standardized data on the right-hand side, which includes a set of unstructured data like reports, media, images, video, and other literature or technical documentation related to a study. Next slide. So just wanted to give you a quick overview of the Delve structure and integrations. Laura is going to be elaborating more on this in her demo, but the Delve system provides a mechanism for users to add new projects into the system. Projects include data sets, files, and equipment information, and there's metadata associated at all of these levels. The metadata allows published projects, data sets, and files to be discoverable through spatial and tabular searches, and then once discovered, allows users to visualize the data at project level and across data sets for exploration. And users will be able to bookmark or save searches or visualizations within the system to access at a later point or share with their colleagues. As part of this phase of development, we're also building a set of APIs to make the data available to open data portals like the California Open Data Portal or the CNRA Open Data Portal, and a data adapter as well for users to do more advanced analysis and visualization with robust tools and software packages like Power BI, R, and Python. Next slide. So as we're building out this system, we see Delve as a node in the larger open data ecosystem, whereby the core system components can be used to serve other departments and divisions within DWR or other agencies or organizations with similar needs to effectively store, manage, and serve up their data, with the ability to add new data categories that could serve as the long-term repository for existing and future data sets and provide connections back to open data portals, all with AB 1755 compliance in mind. We're also exploring an open source license option for the code base by which feature improvements or enhancements made to a particular node could be shared to the other nodes in the network with minimal investment from partner nodes. This shared approach can also help build a community of users where best practices and solutions to common problems can be shared. And with that, I'm going to hand it over to Laura to detail and demo some of these system components. Laura? Laura, are you on mute?
Sorry about that. I had trouble finding the mute button. So Delve was developed with 5 primary use cases in mind. The first was the need to document metadata associated with projects and data sets, and then publishing those data sets to make them discoverable for others. The second is around maintaining data standards. So as Mike touched on, the structured files and data sets that Delve supports are all built around this idea of a data schema. So users can upload their structured data, compare that data to what is expected by the data standards, and then view feedback on potential gaps or incompletions in their data. Really the goal being to encourage best practices for data management and also drive compliance with industry standard protocols for data collection and formatting. Third is related to discovery of projects and data sets. So users can search for projects, data sets by map locations, type, keyword, tag, and assorted metadata criteria, and then download that data for use outside the system. And then these last 2 use cases are really focused on visualization. So initially we focused on visualization for the QA/QC of data. So when users upload a structured file, they can view some basic charts and graphs of the data contents of that file to support QA/QC processes and also to create some summary visualizations for reporting. And then in the near-term efforts, we're focused on more advanced analytics. So both the functionality to explore cross data set visualizations within Delve, and then also through connections to tools like Power BI, R, and Python, which are really the workhorses for that type of advanced data analysis. When we think about the benefits of Delve, it was really underlying all of this effort was a focus on flexibility to fit the needs of various different programs, projects, and users, driving towards standardization where it's important and valuable for these types of structured data to improve interoperability of data collected across different projects and programs, but also accommodating the non-standard. As Mike touched on, we support non-standard data types as well. And then underlying all of this really is this driver to enhance the quality of the data itself, both by making it accessible and more widely available to users, and then also through insight into the quality of the data itself by validating the data contents. So we have a brief demo of Delve here, and hopefully this will work all through the screen share. Pause this and I'll give just a quick introduction. This is a screen capture that I made, and I'll just narrate it as we go through today here. So from the Delve homepage, users can view some high-level information about the system itself, access to external resources that support the work, some insight into featured projects. And then the high-level navigation and use of the system is really focused on projects and data. So users can view projects, upload data, create new projects. From this project page, users can search the assortment of projects in the system, both by viewing a list of all projects, and then there's this map view where users can view the locations associated with these projects. When they click on a pin here, you'll see the name of the location and then the various projects within Delve that are associated with that specific location. On the left side here, users can further filter the criteria and narrow down the projects by assorted specific fields within that data. So for example, searching on species studied, I can find all projects that contain steelhead as one of the species studied in their project metadata. And you'll see when I run this search, the list of projects goes from 35 to just the 9 projects in the system that contain species studied of steelhead. I can also do more general searching with keywords. So for example, if I put in survival here and I search that, it will add a few more projects that mention survival somewhere in the project metadata, whether it's the name, the description, or other fields. And then we have map-based searching functionality through this lasso tool. So I can draw a boundary on the map and it will further narrow the projects that I'm seeing to those that have locations within that boundary. I can drill into the projects, view the list of published data sets that are associated with that project, and then navigate directly to the project page where I can see that project metadata. So we have a number of fields here for things like project description, project team, the species studied associated with the project, for example, locations, keywords, and related links. There we go, caught up with me. So you can see all of that project metadata here, and then users can edit and update as needed. Projects are also associated with both published data sets, which are those that are complete and visible and searchable to other users, and then draft data sets, which are the work in progress. So users can continuously add files and create new data sets by selecting a type and then adding users to be associated with them. And the last component of the project is the equipment level metadata. So users can create equipment records at the project level and then associate those down to specific data sets that use that piece of equipment in the collection process. So you can see here an example data set. Data sets also have their own set of metadata fields. I can export all files within this data set and then also view them individually. And this is where I get some richer feedback about the data quality and the standards. So all of these structured files are associated with a specific file type that defines what we expect the fields to be in that specific file. And then we can view some ratings of the completeness and the cleanliness of that data when we upload it. And then users can also add an explanation if they want to make any notes about gaps in the data itself. And then if I click into an individual file here, I can see more details about the validation of that structured data. So on this validation results tab, I can view what underlies that completeness and cleanliness rating. So I can see here that there are complete fields in my data, and then there are also required fields that are not complete, as well as optional fields that are not required on the completeness side. And then on the cleanliness side, I get some insight into specific entry data points within this file that either fall outside the expected range or format of that specific field type. Then if I go back to the data set level, this is where we can see some of the visualization. So right now, the initial focus has been on visualization for QA/QC purposes. So I can go into this visualization viewer at the data set level view a list of all of the file types that are within my data set. And then each of those file types has can have some assorted visualizations for QA/QC. So for example, if I look at my process detection events file, there's a visualization type for a detection Gantt. And when I click on a specific file, it will display from the data within that file itself, a Gantt chart of the detection date and time for each station that's in my file. The goal being to help users understand where there might be quality gaps or errors in their data. Similarly, the process detection events files have a detection location visualization. So when I navigate to an individual file, I'll see a map with the points that represent the latitude, longitude of where those detections occurred in this data. And as I mentioned earlier, data sets are published and then made visible. So once they're published, they can't be edited directly, but users can come back to that data set, revert it back to a draft state. What we do at that point is create a copy of it, and we create a second version of this data set. And then in that second draft version, or third or fourth version, so be it, users can then go in and make changes, replace files, add new ones, and republish it for other users in the system. And then all of the schemas and the fields associated with these files, as well as the projects and data sets, is driven on the back end through this schema builder functionality. So for example, if I go into this process detection event file type, I can see a list of all of the expected fields in that file, whether or not they're required or optional, and some high-level metrics for what type of data should be included. I can also set up the visualization types that we were just looking at. So for example, this detection Gantt is pulling from specific fields within that file, so that when I upload that file, the system knows exactly how to draw that visualization. And I can create a new one as well. There's a variety of different types of visualizations that Delve supports, from pie charts, line charts, scatter plots, bar charts, a lot of kind of basic standard QA/QC type visualizations. And then the last component of Delve is really some resources so users can get some help when they're using the system, view the data standard documents that drive it all, as well as some user help and resource guides. So with that, we'll pause for any Q&A here. Pull this over, as well as some contact information. If we can't get to your question, feel free to reach out to either Mike or to me later, and we're happy to share more information or answer and follow up.
We have a few minutes for any questions. Peter, has any questions come up on this?
I have one, and the question is, does Delve use Tableau as a backend?
Delve does not use Tableau as a backend at all. All of the visualizations are through a front-end JavaScript library that we use. And then we are working on connectors for Power BI, as I mentioned, in R and Python. Those have been the priority, given they're the most widely used and accessible by the current Delve user group. Not to say that Tableau couldn't be added in there in the future.
Thanks. And I have another question. I might have missed this, but what kind of data does Delve host?
Yeah, I could probably answer that, and also happy to share our presentation deck with anyone who's interested. We had mentioned that we have a set of standardized data categories specific to, at this point, for ADCP, acoustic telemetry, organism sampling, water quality or time series data, experimental observations, and geospatial data. But the system is set up in a way that if we understand other structured data types, the system has the ability to add more structured data categories.
Thank you, Mike. I have another question. Is a Delve portal intended to be internal to an organization or public facing?
Yeah, that's a great question. It's something we're currently working with DWR to expose aspects of the Delve system to the public. Currently, it's only internal to the organization, but we'll keep people updated when we make aspects of the system more public. But as we mentioned as well, we'll be pushing data sets to the open data portal as well. So all of that funnel into the CNRA open data portal.
Thank you. That's all the questions I have at this time.
Okay, thank you. That was another great presentation. And it's exciting to see these tools being built to help us deal with the data and the different kinds of data. I know for many years, things like time data, time-specific data have been really difficult to deal with. So thank you for the work that you've been doing on these tools to help us all with the data that we're dealing with. So if you have any other comments, we actually have a couple of extra minutes. So if you have something else you want to add, we've got a minute to do so. Otherwise, we'll move on. Looks like you've both shut off your microphones, so we'll move on to the next presentation. Our next one is actually a lightning talk, a very short talk by Scott Coffin with the State Water Resources Control Board. And it is a little more specific on this one about microplastics toxicity, called the Untangling the Multivariable Microplastics Toxicity Issue with an Interactive Data Exploration Application. So Scott, if you are ready to turn on your camera and microphone, please go for it.
Thank you, Beverly. All righty, going to request remote control. There we go. All righty. So predicting the toxicity of microplastics is an incredibly challenging it's an incredible challenge because there's so many different polymer types, chemical additives, and there's a continuous distribution of shapes and sizes that all of those components affect the toxicity to humans as well as aquatic ecosystems. In order to make sense of this, we've developed a tool. I'm not able to actually control my slides right now. There we go. Okay, thank you. We've developed Tomex, which is the Toxicity of Microplastics Explorer app. This is an open microplastics toxicity database that was created to assist a health effects workshop that we're convening right now. The goals of this app are to identify the health effects of microplastics for both humans and aquatic ecosystems, prioritize microplastic characteristics that are more toxic than others, and identify critical thresholds for setting regulations. Next slide, please. Included in the database are effect studies, plastic leachate information, chemical absorption, and chemical co-exposures. What's not included is information on macroplastics, field observations, toxicokinetic information, as well as environmental occurrence. For the aquatic organism side of the app, we have 167 publications, 6,000 measurements, 165 in vivo studies and 2 in vitro studies, 3 shapes and 14 polymers, 20 nanometers and 5 millimeters. Included are data for 117 species. We also have a human health side of the app that has 65 manuscripts and 4,000 measurements. Of these, 36 are in vivo and 43 are in vitro studies with 2 shapes and 9 polymers and particles ranging from 5 nanometers all the way up to 306 microns. Mammalian animal models and cell lines are included for the human database. So for each data point, we include information on test organisms, parameters such as pH and the exposure time, effects data, so reproduction, development, particle information, shapes and sizes, and for each study, we rated the quality criteria using 12 independent criteria by 3 independent reviewers. So I'm going to give you a brief walkthrough of the app. And excuse me if it's a little bit grainy right now, but this is what the app looks like. You can explore the amount of data that's in the app by different characteristics, like different organism types, in vitro or in vivo data. You can also look at different particle characteristics to see what type of information is available in the microplastics toxicity database. You can also delve into the data further using the Exploration tab. Here you can filter by different particle characteristics, organism characteristics, as well as test parameters, so that you can build a hypothesis for whether or not you think certain particles or effects or organisms are more or less sensitive. Once you make your filters, what happened to the video? Oh, sorry. We might have to skip that because it seems like it's not working right now. Once you understand more about the toxicity for specific organisms or specific particle characteristics, the app also includes a way to build what's called a species sensitivity distribution, which is a probabilistic estimation of the toxicity for whole ecosystem level, which is typically viewed for, or is typically used by the US EPA, Reach, and other organizations to set water quality objectives. And the way that we've built the app is it allows a user with no coding expertise to walk through the app and both understand the toxicity, but also derive ecosystem level thresholds that can be tailored to specific ecosystems based on organism data as well as monitoring data. It looks like Anna's getting me back to the video here so I can walk you through real quick. Looks like this video is not working, but we look forward to having this be available to the community, and we're hoping that it will be available open access by the end of this year. Ideally, the database grows and we make this available. Here we go. We make it so that people can publish their studies and upload the data onto our database so that it continues to evolve and include more and more information so that we can make both better assessments of risk and understand what further studies need to be done in order to better understand the characteristics of these different plastic particles. So you can see here some different box plots that have been that you can create using this app using the exploration tab. And I'm just gonna I'll cut this off a little bit early, but I did want to show you one of the main parts of this tool is the ability to look at the species sensitivity distribution. So here you can see species sensitivity distribution tab. I mentioned before that you can tailor this to a specific ecosystem. So marine, freshwater, terrestrial. You can even filter by the type of species. Again, quality criteria, and then you can actually, what's really novel about this app is you can switch between particles, mass, volume, or surface area so that you can directly compare toxicity information to whatever metric that you're measuring in the environment. If you're using pyrolysis GCMS or Raman spectroscopy or a different tool that can get you a different metric, you don't have to do those conversions. The app can do all of those conversions for you. And so this is an incredibly powerful tool that's built on an R-Shiny platform and some established R packages. And so I just want to be mindful of time. So I'm going to actually skip ahead to the next slide here and just thank my contributors, fellow collaborators at Southern California Coastal Water Research Project, University of Toronto, San Francisco Estuary Institute, as well as several organizations and universities in Europe. Again, the app, we're still building it, and we hope to make it available to the public in fall of winter. If you want to find out when the app is available, please follow us at Tomex app on Twitter. And hopefully we still have a few minutes for questions. Thank you very much.
Hi, yeah, Scott, we do have a few minutes. We've been picking up a couple with each presentation. So if we have any questions, you've got plenty of time to respond to them.
Hi. The first question is, which groups of organisms are the best represented or most underrepresented?
That's a great question. So we almost have no information on terrestrial organisms. We have a lot of information on aquatic organisms, mostly crustacea data. I think we have about 10 different crustacea species. We also have quite a few fish species. And so far, it seems that fish and crustacea tend to be the most sensitive to microplastics. We also see about 10 orders of magnitude in species sensitivity differences. So quite interesting that certain species are far more sensitive than others.
That is interesting. That's all the questions I have for right now.
Thank you.
Okay, thank you very much. Again, another really interesting, exciting tool that you guys are working on. Microplastics, of course, is something that's just come up as a big issue in the last several years. So this is really timely, and I'm glad you guys are working on this. Thank you.
Thank you.
And we're going to be moving into a few presentations about groundwater tools. So our first one, and we are a little bit early, is looking at a groundwater quality map. And the presenter here is Hung Bui with the State Water Resources Control Board, Division of Drinking Water. So this should be very interesting. We all like maps, and it's a nice way to visualize things. So Hung, as soon as you are ready to go, you can take over.
Thank you, Beverly. Can you hear me?
Yes, we can. Take it away.
Thank you. Good morning, everyone. My name is Hang Bui, and I am an associate sanitary engineer at the State Water Resource Control Board, Division of Drinking Water. Today, I would like to share with you a geographic visualization tool called Water Quality Map. And here is the outline of my sharing. I will start with some background information on what we do here at Division of Drinking Water, or DDW for short. Then I will talk about some of the tools that we use at DDW to do our daily job, which are the Modified and Public Drinking Water Watch application. Then I will share the features and advantages of the water quality map, followed by a demonstration of the application. Finally, I will invite you to look under the hood of the app to see how water quality map is put together. DDW is the enforcer of the Federal and California Safe Drinking Water Act. We regulate about 7,500 public water systems to make sure that the water delivery to the taps of Californians is safe to drink. We fulfill this mission by conducting inspection of public water system, reviewing their water quality monitoring programs, and taking enforcement action when they non-compliance. Reviewing water quality data is the job activity that inspires us to create water quality map, which will help our staff to perform this activity more accurately and efficiently. The field operation branch of DDW is divided into 24 district offices, which are grouped into 5 sections, from section 1 to section 5. Each section is presented in a different color on this map. At DDW, we have an application that helps us to do our daily job called Drinking Water Watch. And there are 2 versions of Drinking Water Watch. The modified version, which is an internal version serving our staff, where the public Drinking Water Watch is available to the public on the internet. Here we have a screenshot of the homepage of Modified Drinking Water Watch, and its access link down here. And here is the homepage for the public version of Drinking Water Watch with its web address. Water quality map is a part of the Modified Drinking Water Watch application, where user can visually examine California source drinking water quality data, regionally as well as locally. These are key features of the water quality map, which will be covered in detail in the demo. Here we are looking at a screenshot taken from water quality map, where it displays nitrate detection in Visalia district in Central California. We can see that the nitrates detection are concentrated where agricultural activities are, and higher detection are found on the east side of the map, and the level of detection decreased from east to west. So a well site chosen to the west side of the map will more likely have a better water quality. It is critical for our staff to be able to review the latest data from our database of records to make compliance determinations. And to that end, water quality map display live data from DDW's production database. And the remaining advantages will be covered during the next demo. Now I'm going to switch to the demo. First, we will enter the web address for the Modified Drinking Water Watch application into this bar and press enter to be taken to the home page of the application. And then we will click on the water quality map here. And we will be taken to the landing page of the water quality map. On this page, we can search for water quality data by county or by regulating agencies. Developers at DDW prefer to search by regulating agencies. Now we will look up PFOS levels in Orange County using the regulating agency, which is District 8 in Santa Ana. For analyte, I'm going to enter PFOS and select this analyte and click on View Map. The water quality map will be loaded after the form. As you can see, the maps show locations of all PFOS detection in Orange County with a summary of detection on the left. There are a total of 124 detections of PFOS in Orange County. Of these detections, 107 samples are greater than the NL level of 6.5 nanogram per liter. NL or notification levels is the level at which a water system must notify their governing body when they have that detection. On the map, detection are plotted as color-coded circles centered at the facility location, with the circle's radius representing the contaminant detection levels. And the size of this circle can be adjusted using a slider. As you can see here, you can make the circles smaller or bigger that way. The color of the circles are determined by how the detection level is compared to the maximum contaminant level MCL or notification level NL. For example, here we have the red circle here where the level are greater or equal to NL. We also have some yellow circle and green circle here. And here is a pie chart showing the percentage of sources that exceeding the NL. This chart shows that 86.3% of PFOS detection in Orange County are above the notification level. Location of wells and treatment plants are shown by markers. These are markers. Blue markers are where the wells are located at, where the pink marker like this one mark the location of the treatment plant. And these marker can be toggled on and off by checking these boxes here. On this map, we can also toggle on and off the water system boundary and the district of office location by checking these boxes. Now let's click on one of these marker to have the info window display. As you can see, at well 54 in city of Anaheim, the latest detection was 24 nanogram per liter on April 7 of this year. And if I click on the view on sampling results link here, and a table will be loaded below the map. And this table allows us to view, print, or download on the PFOS data at this well to date. And below the table, there is a line chart that shows the PFOS water quality trend over time, which seems to be decreasing. And we choose PFOS for the analyte, but user can switch to any other analyte by entering, the first few letters of the analyte into the box. You can see we have a list of all the available analyte to choose from here. And with that, I will return to my slides to look behind the scene of the application and show you how the map is put together. Now I'm going to switch. Now I'm going to switch to the demo. Sorry about that. In the back end, water quality map draws data from two principal databases at DDW. SIGWIX, short for Safe Drinking Water Information System, and WQI, short for Water Quality Inquiry Database. On the front end, water quality map is a collection of mapping components and visual components, which we will examine in the next slides. Our application has a base map that's fed by Google Maps JavaScript API. On the top of the base map, we added 3 layers, which we will analyze in the next slide. In the first layer, we query the SIGWIX database for facility locations. And then we look through the result set to set a marker at each well or treatment plant location using their coordinates. And during each iteration, we query the WQI database for the latest sampling results of the analyte selected by users. The query result then is compared to the MCL to draw the color-coded circles in the second layer. Finally, the last layer of the water system boundaries is a GeoJSON layer, which is hosted on the WaterBoard's GIS server here. Yes. For visual components, we use Google Visualization API to draw graphs. In contrast, the dashboard is coded with simple HTML, CSS, Java, and JavaScript. In summary, in doing our job as a regulator, we also become the custodian of critical data on our environment. With adequate resources, we will be able to create data visualization from which we can draw insights. The insights, in turn, will help support our data-driven decision-making processes. And with that, I will be looking forward to responding to your questions or comments. Thank you for your listening.
Thank you. That was another great presentation and a really interesting tool. I suspect that there are probably questions about whether it's accessible or not. We'll ask Peter and see if something has come up in the questions.
That is exactly the question. When will the water quality map tool become publicly available?
Thank you for the question. Yes, currently the application is available internally for the water board staff, but we have a plan to push it to the public version of Drinking Water Watch in the future. I don't have the time frame, but I would say in the a couple of months we try to do that. Yeah.
Great, thank you. That's all the questions we have.
In that case, I will ask a question. Is this tool connected directly to data so that it's automatic updating, or are you updating it on a specific time frame?
That's a very good question, Beverly. Thank you for that. Yes, the data is extracted from the our production database, so there will be no refreshing needed. As soon as the lab submit data sending this on to the database, or as soon as you make a change in the well location or anything like that, the data will be reflected on a map instantly. And that's what sets us apart from other similar tool that you see on the BOA website. They all draw data from a copy of the production database, and then therefore that must be refreshed, periodically.
That's fantastic. Thank you. And when it becomes publicly available, is that still going to be the case, or is there going to be a lag between data going into the database and going on to that publicly available map version?
When we push it on the public version of Drinking Water Watch, and it will still be the case. There will be no lag involved. Yeah.
Very good. Thank you. I don't know if any more questions have come up. Peter, one last check. Is anything else surfaced?
Nope.
Okay, well, thank you very much. These presentations have been really exciting for me to see. Working with a lot of State Water Board data, it's often not easy to get some of the data out and be able to compare between different sets of data and different databases. So these tools that are being developed are quite exciting, and I'm glad to see that they're coming out to help us get the data available to the public as well. So thank you very much.
Thank you.
And we'll move on. We're still looking at some groundwater tools. So the next presentation is by Christina Babbitt with the Environmental Defense Fund. And her presentation is Advancing Sustainable Groundwater Management with Open Source Technology from Vision to Reality. So Christina, you are ready to go.
Perfect. Thank you so much, Beverly. It's great to be here today. And as Beverly mentioned, I'll be talking about some work that we've been doing to advance work on sustainable groundwater management. And more specifically, I'll be providing an overview of an open source water accounting and trading platform that EDF has co-developed with partners, including John Burns at Sitka Technology Group, who's my co-author for this presentation, and as well as Rosedale Rio Bravo Water Storage District in Kern County, Westwater Research, OpenET, and Olson Engineering. And at the end of my overview on the platform today, I'll highlight how we'll be continuing some of this work to scale the platform with the California Water Data Consortium and state and local partners. So just trying to advance the slides here. Let's see if it works. I don't seem to be able to advance them. So was I granted remote control?
You need to request it.
Yeah,
and then,
you're
yeah. Do you want me to just say next, or do you want me to? I requested control to just advance the slides. So you tell me what works best.
I can advance for you.
Okay, perfect.
You might have control. Somebody is sort of fighting me for control. So.
Okay, well, I don't seem to be able to, so I'll just say a bunch of next, and
okay,
thanks
cool.
for your help.
Yep.
You can go to the next slide. And one more. Perfect. So as that slide transitions, I'll jump into talking a little bit more about the platform. So in 2018, Environmental Defense Fund worked with Rosedale Rio Bravo Water Storage District in Kern County, and you're seeing a map of the district on the screen. And they were our core partners in building out the platform. So just a little bit of background on the district in case you're not familiar with them. Rosedale is located in the San Joaquin Valley. They're really located in the heart of groundwater overdraft. They manage around 44,000 acres of land, and around 27,000 acres are planted in irrigated agriculture. And about half of this irrigated acreage is planted in permanent crops. And under SGMA, they are a critically overdrafted basin. Next slide, please. So this slide shows a screenshot of the water accounting platform. This is the Rosedale's homepage. And the platform was designed to enable water managers and farmers to develop more accurate water budgets, facilitate water trading, and to help minimize undesirable results through the use of a groundwater modeling decision support tool. The accounting portion of the platform was launched in Rosedale of March of last year, and the trading features will go live once trading is needed, once scarcity is demonstrated within the district. Next slide. And so I always like to mention that the platform was co-created with landowners and water managers in Rosedale. And in 2018, we hosted a series of workshops. And during these workshops, we heard loud and clear from different landowners that they wanted something straightforward and easy to use. And so we really kept this top of mind as we built out the platform. Next slide, please. So this graphic illustrates the main features of the platform. I'll briefly touch on each of the core components, and then I'll share some screenshots of the actual platform. So at its core, the platform is an accounting platform. It allows landowners and water district staff to track their annual water allocations and current water usage in near real time. And it's pretty similar to a bank account, right? You can go online and you can see the status of your account. And so within the core functionality, water use is provided by a project called OpenET. And this is a platform being developed by Environmental Defense Fund, NASA, the Desert Research Institute, Google Earth Engine, and many other partners. You can actually go back one slide and I'll just tell you next. Sorry, thanks. And so this is a platform that is providing open source kind of evapotranspiration data using satellite data. And this satellite data is really particularly well suited for Rosedale because they're basically a water storage district. They bring in surface water, recharge it onto the ground, and then landowners primarily pump this groundwater. And so they don't have the more complex surface water, groundwater, pumping use interactions that many districts do. But as we scale out development of the platform, this is something we'll be paying a lot of attention to in terms of the additional data sets to incorporate to track that water usage. Next slide. Water supply in the district is managed by the district, of course. The district can input detailed water budgets for landowners. For example, they can set a water allocation or target usage for each field or landowner. And this also allows them the opportunity to define different types of water. So all the buckets of water that are coming in are not always the same, and they often have different rules associated with how they can be used. The next slide will bring us to the water budget. And then when you measure both water usage and supply, the landowner and district can really better understand their water budget via either a landowner dashboard or a water manager dashboard, which I'll show you in just a minute. Next slide. And so water trading is an optional feature that can be added on top of the accounting portion. The accounting portion is, of course, fundamental to enabling trade to move forward as one option to help landowners more flexibly manage their water resources. And then the next slide will show us the opportunity. Once you better understand your water usage and availability, you can do deeper analysis. And so we've worked with a group out of Nebraska called Olson Engineering to leverage a groundwater modeling decision support tool that they've developed to run through potential scenarios that leverage groundwater models to help water managers better understand their management actions before they take place, such as in the case of trading. And so with this platform, we've developed it all open source because we think it's really important to be able to scale accounting from kind of more local to broader scales. And with this open source license, of course, there's no fees, and districts can adapt it to their particular need, working with the partners that they choose. Next slide, please. So with that, I'll quickly share some screenshots from the platform. And you'll notice the branding on this platform that you're looking at now is EDF. And so what we did was develop a demonstration platform that anonymizes the landowner data and the parcel boundaries so that we can allow people to log on, create a free account, and access the full functionality of the site. Next slide, please. So when we log on to the accounting platform, we're now looking at the manager page, and you can see this district-wide statistics such as, how much water they manage, the different buckets of water that they have, and you can toggle between acre feet and acre feet per acre. And then if you look at the right, you can see this information in graphic form. And so you can see we're looking at 2021. We have OpenET satellite-based ET data loaded from 2017, but you can see water data through 2017. Right now we're doing manual uploads of the data because the OpenET project will launch officially later in the summer, and then they'll be automated. And then you can see the average annual usage through the gray bar, and you can see the water supply or the water cap allocation in red. Next slide, please. And then if you scroll down on the water manager page, you can see all of your landowner accounts. They each have a unique account number. You can see how much they're allocated across the different types of water. You can also see any trading activity that is taking place, and you can toggle between the different years. Next slide, please. And then if you scroll down further, you have an interactive map where you can go to different parcels and then access that landowner page. Next screen, please. Next slide. And so now we're going to transition to look at the landowner page. We just saw the manager page, which shows information across the district. And all of these landowner names were randomly generated, so they're a bit funny. We're looking at Whittier Farms right now. And you can see, same format as the water manager page. You can see how many acres they manage, what the allocation is, if they've engaged in any trading activity, and some cumulative statistics of water usage to date, how much they have available. And then also graphic representation on the right using that OpenET satellite-based data. And then you can see that this water user is using under their allocated amount. And so they could be a candidate for trading if water trading were enabled. And in fact, this person, if you look at the sidebar on the left, you can see that they have engaged in a water trade. Next slide, please. And so if you click on any of these plus buttons, you can expand what you see under that. And I just wanted to highlight that within Rosedale, they've defined 5 different types of water. And it's really important to define these types of water because there's often different rules associated with their use. For example, when water trading comes on board in Rosedale, that project water is that surface water that it comes in, is recharged under the ground. That will be water that they will be able to trade. But for example, native yield, that water that percolates underground and is used by overlying landowners, that will not be tradable. So these types of water really influence the kind of management actions that can be brought forward in the district. Next slide, please. And so these are just screenshots. I wanted to show the different years of data that we have for the water usage data from 2019, 2020, and 2021. Next slide, please. And then if you go across different screens, you can see the information in different tables or graphic representation. You also have an interactive map where you can see where your parcel is in relation to the district boundaries. Next slide, please. So in terms of water trading, as I mentioned, we heard loud and clear that people wanted something that was easy to use. And so essentially the water trading within the platform is a Craigslist type system. The district wants to be able to connect buyers and sellers of water, but they don't want to be engaged in the financial transactions. So it allows landowners to find each other create a simple posting, and then once the terms of those trades are met, each of the landowners then can register the trade with the district, and that then gets incorporated into the trading or into the accounting portion of the platform. Next slide, please. And if you'd like, you can also within the district create market metrics, which kind of share some aggregated overarching statistics on water trading in terms of quantities, amounts, and prices. Next slide, please. And so the last part of the platform I'll highlight is the groundwater management kind of scenario planning tool that we've worked on with Olson. And this is just a screenshot of the scenario, but you can go to, I'll give you a link at the end, which allows you to go to the platform and you can run these scenarios out. But it's really important to understand potential management actions and how they could impact other users within the basin, either if there's an impact or even a benefit. So right now we're looking at a potential groundwater trade. This is a trade for 600 acre-feet of water. The parcel in blue is no longer pumping, so you're seeing groundwater levels slowly rise. The parcel in red is the buyer of water. They are now pumping, so you're seeing those groundwater levels slowly decline. We've mapped a nearby disadvantaged community and some domestic drinking water locations, because it's really important to understand as you allow these trades to take place, what those potential impacts are. And this is of course one trade, but it's really important to understand those trades cumulatively through time. So this type of tool can help inform trading rules, but it can also allow you to better assess cumulative management activity through time into the future. Next slide, please. And so of course, I probably don't need to tell this group, talk about the merits of open source, but we're really excited to be developing this work open source. We feel that there's a lot of benefit in terms of the resources that are put into the platform. It will of course be an optional tool, but all the functionality that gets built out, within the work that our partners are doing or others will then be available for others to use. And I think with groundwater accounting especially, there's just a real opportunity to kind of leverage that information across, local to more regional scales to understand water usage and availability. And of course, we hope that this also lowers the cost for folks to be able to adopt these types of systems. Next slide, please. And so lastly, I'll just touch on some work to scale the platform. We're really excited to be working with the California Water Data Consortium, the Department of Water Resources, the State Water Resources Control Board, and many local partners to think about how we can build out the functionality of the platform to support SGMA implementation more broadly. This, of course, as I mentioned before, is an optional tool. And we're really excited to be working with different landowners, stakeholder groups, community groups, NGOs, academics, managers to really inform how the platform gets built out into the future, what additional features and functionalities are needed to really best support these management decisions through time. Our goal is not to reinvent the wheel. We understand that lots of folks have been working on accounting for a long time, and we'll be working with groups to see how we can really be additive to kind of enhance and move forward accounting of groundwater in California. So in terms of next steps, we'll be focused on integration of additional data inputs, such as incorporation of metering data. We'll be expanding the accounting functionality of the site, including the integration of groundwater level data. We'll also be further integrating the open source scenario planning tool to help managers evaluate management actions. And then we'll be working closely with the California Water Data Consortium on their work to co-develop common groundwater data standards that will then be used within the platform. It's really important to kind of ensure that this platform is compatible with other online electronic portals that local and state agencies use, such as the SGMA portal and the consortium's GEARS program. Next slide. And so just to learn more, if you're interested, you can log on to the demo platform, create an account. We've created a story map on the project, and you can visit and look at the source code as well. Next slide. And that's it. With that, thank you so much for your time, and I really appreciate your help navigating the slides as well. So thank you.
Okay, thank you, Christina. I think we probably have some questions. And just as a reminder, if you do have any questions, please type them into the Q&A feature at the bottom of your screen, and we'll make sure that the questions go to the speaker. So Peter, do we have some questions for Christina?
Yes, we do. We have a few. The first being, have you incorporated climate change impacts or climate change models into your platform?
Yeah, that's a great question and really an important consideration in managing water moving forward. So we applied for a Bureau of Reclamation Applied Science grant to really forward some of the scenario planning work that we're doing. And we find out hopefully next month whether we've received that grant. But what that grant will allow us to do is further develop the open source iteration of the scenario planning tool, but it brings in ModFlow models and will also work with a state groundwater model that's being developed. So that is a focus. So to the extent that these models incorporate climate change data, it will be kind of factored in, but that won't be the focus of our research moving forward in terms of like the work that we do to integrate climate scenarios. But we're really interested in kind of what needs are out there and how you think that type of research or work could fit into the platform. So please reach out and would love to brainstorm ideas.
Great, thank you. And how is the water allocation budget for each landowner determined before the water trading?
Yeah, that is a great question. And it's a really complex answer, but you know, it's really determined at the local level, right? GSAs have the ability to allocate. It's pretty complex in terms of what those allocations look like because they still need to follow water rights law, groundwater law. But really the platform that we're developing allows water managers to kind of put in those numbers and account for the allocations, but actually deciding on what those allocations are really a local kind of decision that need to be broadly kind of bought into by different stakeholder groups. So, and there's a lot of GSAs, groundwater sustainability agencies right now that are kind of working through that process.
Thank you. Is this publicly available and where? I think you said yes, and if you wouldn't mind putting that up in the chat, that would be great. And the second part two of this, is it possible to track infiltration during the wet season, for example, ASR or other stormwater capture measures? Does that affect the market availability?
Yeah, great questions. And I'm not great at double multitasking. So as soon as I'm done answering the second part of the question, I'll put all those links in the chat. And then if you go to the link I'll share, which allows you to log on and get a demonstration account, that same page, you don't have to log on, but you can see two different scenarios we've drafted. The one I showed you today focused on water trading, but the other one focuses on groundwater recharge in terms of opportunities to, for at least in Rosedale, they have a lot of recharge basins. If they're deciding on where they want to recharge water, it could, you could use the groundwater models and then kind of overlay some geospatial data to decide if there's like the potential to have benefits or areas, you have water quality areas you might want to avoid. But I will say the scenario planning tool that we've developed, at least right now, I think it's an initial scenario planning tool, which allows you to better understand trade-offs. And there's been a lot of great work done by groups like Sustainable Conservation with like really detailed like information on the soil and kind of aquifer and recharge. And so I think there's a lot of opportunities to kind of work with other groups who are doing really cool projects to better understand decision-making at different levels, depending on what your needs are. And then I do think, you know, groundwater recharge in terms of tying into the market, you know, I think it is linked. It's part of, you know, another bucket of water in terms of you know, what is available and then perhaps opportunities to trade that. But there's lots of kind of complexity within those questions as well. But there's an accounting portion that definitely ties in as well.
Great, thank you. That's all the questions we have.
Okay, perfect. Well, thanks so much for your time. I'll put those links in the chat. And again, thanks for the help navigating the slides. Take care.
Okay, thank you so much, Christina. That was really interesting. And we're going to be moving into our final presentation for this session in just a minute, but I want to point out that we may have a few extra minutes at the end. So if there's questions that you've thought of for some of the previous presenters that you would like to try to get their responses to, please go ahead and put it in the Q&A, and we might be able to address those at the end of this last presentation. But without further ado, we have gspdrywells.com, an open source tool to estimate impacts to vulnerable wells and support GSP development, being presented by Rich Pauloo of the Water Data Lab. So Rich, you are able to take over and start your presentation.
Awesome. Thanks for that introduction, Beverly. My name is Rich Pauloo. Today, I'll present gspdrywells.com. It's a project to support vulnerable well protection, planning, and analysis for GSP development, and ultimately drinking water security. Next slide, please. Oh, that's my title slide. Next slide, please. All right, so first a quick thank you and gratitude to co-authors, advisors, and funders. This work is the result of many conversations and collaborations across the past 3 years, and many people and organizations have contributed significant ideas, time, and funding. So a big thank you to all. Next. First, before I start with California, I want to zoom out to a global picture. Groundwater provides drinking water for about half of the global population and about half of all irrigation water. Roughly 1 in 3 people on Earth depend on groundwater for basic daily needs. Next slide, please. And groundwater is water in pore or fracture spaces of subsurface sediments. It's naturally replenished by rainfall, stream flow, irrigation recharge, and so on, usually over very long timescales. And extracting that groundwater at a faster rate than it's replenished has led to chronic groundwater level declines in aquifers worldwide. Next slide, please. And we can see those declines here. This is data from the NASA GRACE satellite, which measures mass fluctuations across the Earth's surface. And groundwater withdrawals are among the largest changes in mass detected from space. Red colors indicate declining water storage and hence higher groundwater extraction. And you can notice California's Central Valley light up on the map here. Next slide, please. In the Central Valley of California, these satellite images show winter snowpack, which is our surface water supply between 2018, a dry year, and 2019, a wet year. Consequently, we used more groundwater in 2018 than we did in 2019. And importantly, 85% of Californians rely on groundwater for some portion of their drinking water supply. Next slide, please. Chronic lowering of groundwater levels caused by overextraction, particularly in drought years, can result in impacts to shallow, vulnerable wells. So during the last drought, around 2,000 domestic wells were reported dry in the Central Valley, primarily impacting underserved communities. Bottled water delivery was common, and California distributed around 35 million in drought-related assistance, mostly for emergency water tanks. Next slide, please. So in that previous slide, those pictures were taken during the 2012-2016 drought, and California passed the Sustainable Groundwater Management Act, or SGMA for short, during this time period in 2014. SGMA aims to prevent significant and unreasonable impacts to beneficial users of water, and it does so, among other ways, by specifying what are called minimum thresholds for groundwater level. But SGMA doesn't say who beneficial users of water are, and not all plans submitted thus far include protections for wells. So to illustrate, red dots in the map on the left are locations of the reported well outages during the 2012 to 2016 drought, and all red ones in the map on the right are locations that don't yet have a well protection program. And this, I think, is partly due to timing. So well construction data that support well protection planning only recently became available in 2017 in digitized machine readable format. And the first well impact models were published in 2019. So there was a sort of misalignment between the data and models and the planning process. Next slide, please. But put plainly, to summarize, we don't know how minimum thresholds, which is we can think of as our absolute worst case scenario, could impact wells. And if we consider wells beneficial users, this is a big problem. So California needs data and decision support tools to assist GSP development around this issue. Next slide. So let's start getting into it now with respect to GSP dry wells. So how are wells even impacted to begin with? Well, wells, first of all, are like straws into an aquifer. And as groundwater levels decline, water access is increasingly lost unless we change the construction of those straws. So here's a simplified model of well impacts. Moving from left to right, we have an active well. As the groundwater level approaches and then drops below the pump, it's increasingly dewatered. The pump may be damaged and the pump may even require lowering. When groundwater declines below an operating margin spaced above the completed depth of the well, or the bottom of the well is increasingly dry and well deepening may be required to keep the well active. Next slide. So for GSP dry wells, we gathered and cleaned all available data on wells and groundwater levels in the Central Valley and used various supervised learning methods to impute missing pump locations, kind of filling data gaps, and interpolate groundwater levels across space and time. And then we modeled impacts to each active domestic well in the Central Valley. Next slide. We compared and calibrated our model to reported well outages during the 2012 to 2016 drought and found good alignment in spatial patterns of well impacts at a regional scale. At a local scale, refinements are needed. These results are detailed in a paper published last year in Environmental Research Letters. Next slide. And since then, 3 additional studies focused on critical priority basins have assessed how MTs, or these minimum thresholds, may impact vulnerable wells. But even assuming if all GSPs adopted a vulnerable well protection plan, decentralized governance at the GSP level implies potentially hundreds of different approaches to the same problem. So this is a sort of communication and coordination nightmare for regulators and local agencies. The regulators have to evaluate and interpret each submitted plan, which may be different from the next. So this is all underscoring that technical leadership and accessible data and tools are needed to streamline planning and management and to really tie the link and enhance that communication between local agencies, regulators, and communities. Next slide, please. So this is where GSP dry wells comes in. It's an online portal that provides an open data, provides scientific methodology, provides a model, and it provides results. Users can download data and results to conduct their own more refined analyses at a local level, augmenting the model and data therein with local data. Or they can use the web interface as a first cut to visualize and explore well impacts according to these minimum thresholds, or an arbitrary uniform groundwater level decline scenario ranging from 0 feet to 300 feet. So the groundwater level declines 10 feet, 20 feet, 30 feet, 300 feet, how many wells are potentially impacted and where. The homepage is a big picture view of the critical priority GSPs that have already submitted plans for review, for which we can estimate the minimum threshold surface, which sets an absolute worst case scenario, upper bound on anticipated well impacts. Next slide, please. Users can drill down into a specific GSP by clicking it on the map or selecting it in the left-hand drop-down toolbar. In addition to viewing the minimum threshold surfaces and downloading those too, users can select those arbitrary groundwater level decline scenarios ranging from 0 to 300 feet and zoom into the map to view the location of impacted wells. So in this screenshot, red wells are impacted and blue wells are active at the selected 20-foot decline scenario, which you see in the blue box. Question mark icons in the next to the titles of these subplots, and the colorful value boxes are clickable and they expand information on how to interpret graphics and numbers. Next slide. But importantly, it's not all about visualization and analysis, but rather, this open, clean, analysis-ready data, which previous speakers have spoken about with respect to their projects. That open data is really essential. So we provide that data and metadata for manual download on the data subpage. And we also have a methods subpage, which summarizes the approach, and instructions subpage with instructions on how to use the dashboard. Next slide. And for those that prefer to read the data and results directly into R or Python to build a reusable code around these data and results, we provide code snippets that accomplish this, shown here. Next slide. So this is my last slide, and I want to summarize where we've come and where we're going. So we've built a scientific foundation and a web tool to communicate results and share data. Next, we want to make it more accurate on a local level. And we'd like to include MOs, or the measurable objectives. These are not the worst case scenario, which are the MTs, minimum thresholds, but rather the measurable objective, where the basin aims to go over the implementation horizon. So we'd like to include that as a scenario in addition to the minimum thresholds. We also think it's important, and we're in a 2-year drought right now, we think it's important to add drought forecasts similar to those that we published on the PPIC blog, shown in this figure on the right. So this was also in Cal Matters, where we forecasted well impacts, assuming some drought scenarios. So we'd like to integrate that into the tool. But perhaps most importantly, it's really about the people, it's about the analysts, it's about the GSAs, the hundreds of GSAs that are implementing all of this. Like in line with what Christina was speaking about previously, how do we give tools to basins to self-solve issues at a local level? And what are the things that we can do with open source to accomplish that? So we'd like to organize the well impact model, which currently all the code is there and you can view the model, but it's not as out of the box and easy to use as an R Python package you just download and start using. So we want to make that model into an open source R package that you could just install .packages. And this will enable analysts across the state working on each GSP to download and run the model on their own with more locally refined data than this tool can ever hope to integrate or be the definitive source of information. So that's all. Next slide is my, I guess, conclusion. And in conclusion, wells are beneficial users of groundwater. And we can and we should make use of available data and tools to protect them.
Thank you, Rich. That was great. That's a very interesting tool to be able to groundwater levels and look at the impacts to vulnerable wells. With one more reminder, if you do have a question or a comment, please type your information, your question into the Q&A at the bottom of the screen. And with that, I don't know if we have any questions for Rich. Peter, do we have any?
There are no questions at this time.
And has anybody else, has anybody entered questions for any of the speakers? It looks like we're actually getting a barrage of questions come in right now. So I'll go back to Peter with that.
Yes. Was this project initially part of the California Water Data Challenge, Rich?
Yes, actually I guess the germ of this project, the seed, was the 2018 California Water Data Challenge. And so, yeah, that was the initial version of this model before we, published it and made this. This project was supported by a Microsoft grant, but the initial version, yeah, grew out of the California Water Data Challenge. So, big shout out to them for supporting this.
Great, thanks. And was the imperviousness considered in terms of land use change, for example, change of population growth?
Was the imperviousness considered, as in the imperviousness of a surface to recharge? I'm not sure I understand the question.
I'm not sure either, and that's all I have to go on. Was the imperviousness considered in terms of land use change, for example, change of population growth?
I see in the chat, yes, imperviousness for infiltration. We weren't directly modeling infiltration in this study. The way the model works is you have a set of wells that you estimate the location of their pump. And we also have an estimate of the groundwater elevation. And by intersecting those data, we can figure out which wells are likely to be dry and which wells are likely to be active. And then we can vary the groundwater elevation, for instance, in these uniform decline scenarios or a minimum threshold scenario, and estimate the number of wells impacted under those conditions. So that's, I'm not sure if that answers the question, but that is how the model is working.
Thank you. And if you can you please post the citations for the papers you mentioned into the chat?
Sure. I mentioned a handful of papers, but almost everything, I believe everything that that was in the slide deck, which should be made available. The citations are there, so they can be Googled. And then under gspdrywells.com, there's a methodology subpage in the header. And if you click on that and scroll to the bottom, there's a list of citations, and the context of those citations is given in the body. And I see Anna just shared that, so thank you for sharing that. So see the citations at the bottom there, and hopefully that will be a better repository of all of the things that I have cited in this presentation.
Great, thank you. That's all the questions we have.
Okay, that's great. Thank you very much, Rich. And for those people who haven't been looking at the chat, a lot of links have been provided there during the course of the presentation. So if you were wondering if you could access certain things, those links might be available there. So please go back and take a look at the chat section. And with that, that's the end of our presentations for this session. I don't know if Greg has something that he wants to say just before we break for lunch. We've got a few extra minutes, so if he doesn't have anything, then we can let you go and have a little bit longer to enjoy your lunch.
Thank you so much, Bev. I just want to say thanks to all the speakers and acknowledge that the folks that cannot see the chat, we will make those links available on probably an answered question or some other mechanism. So thanks everyone, and have a good break. Get out and stretch your legs, and we'll see you at 12:30.